All right, hello math fans. All right, so what we're going to do today is something called Pascal's triangle. Okay, so first of all, let's develop it, and then I'll tell you how it's used. Okay, so it's pretty easy. You basically have ones, it's just like a triangle here. And you can go as far as you want. Okay, but the deal is the two numbers above the number, like a triangle, you add those together. So in other words, this case here, it's 1 plus 1. So you put a 2 here. These numbers, 1 plus 2. So this one's 3. 1 plus 2, that's 3. Okay, 1 and 3, that's 4. 3 and 3 is 6. 3 and 1 is 4. The next one is 1 and 4 is 5. 4 and 6 is 10. 4 and 6 is 10. 4 and 1 is 5. Okay, then you would keep going. You would say 5 and 10 is 15. 10 and 10 is 20, etc. Okay? So that's what Pascal's triangle is. Let me show you kind of how it's used here. We're going to delete this. And I'm going to write down, the last one I wrote down was 1, well, let's actually rewrite it here a little bit. Let's make it smaller though. So I'm just going to put it in the corner here. So this is 1, 1, 1, 1, 1, 1, 1, 1. Okay, so this is 2, and this is 3 and 3, and this is 4, 6, and 4. And I'm just going to do one more, because I want to do one more. That's 5 and 10, and I did this before, and 5. There we go. Okay, so that's just a mini Pascal's triangle. Now, next to this, we're going to have an exponent. So the one that goes with the first one is exponent of 0, exponent of 1, exponent of 2, exponent of 3, exponent of 4, and exponent of 5. So this is the deal. If I have x plus y to the 0 power, do you guys agree? Anything to the 0 power is 1. So that's my first, see exponent of 0? There's the coefficient of 1. Okay, let's do x plus y to the first power. Well, isn't that x plus y? What are the coefficients? Isn't the coefficient 1 and 1? There you go, 1 and 1. Okay, if I do x plus y to the second power, I get x squared plus xy plus xy, or plus 2xy plus y squared. Aren't the coefficients 1, 2, and 1? There you go. Okay, and if I even went further here and I did x plus y cubed, okay, I would actually have to write out as x plus y and then multiply that by this squared, right? Which is x squared plus 2xy plus y squared. And if I FOILed or multiplied that out and simplified, I get x cubed plus 3x squared y plus 3xy squared plus y cubed. So you go, there you go. Again, the coefficients are 1, 3, 3, and 1. 1, 3, 3, and 1. So these numbers here, Pascal's triangle gives us our coefficients for binomials. Right? That's after we expand our binomials. That's really, really important. Okay, so it's our coefficients. I want to point out a couple other things here too. If you notice that our first term, see how that's x cubed? It's really x cubed y to the 0. And this next one is 3x squared y to the first, and then plus 3xy squared, and then plus x to the 0 y to the third. So what's going on is you have you really have both variables here, except you notice that the x starts out to the third, then it goes to the second, then it goes to the first, then it goes to the 0 power. Anything to the 0 power, of course, is 1. Same thing with the y. The y starts out with a 0. That's why it's just x cubed, because x cubed y to the 0 is x cubed times 1, or x cubed. Y to the 0, y to the first, y to the second, y to the third. Okay, so that's an important concept to see that too. And then if we kind of put it all together, we can come up with, it's called expansion. Binomial expansion using Pascal's triangle. So I'm going to even write that out here. Binomial expansion using Pascal's triangle. All right. So we're not going to, let's see, I can try, let's do, I'm going to get rid of this left side now. Okay, as long as you guys understand what we're doing here. These are coefficients, and you start out, and see this, also I should mention this too, this x cubed is your first term. So it's basically the first term, before I do an example, the first term to the third power, and the second term to the 0 power. And then it's the first term to the second power, and the second term to the first power, and then it's the first to the first power, and second to the second power, and last it's first to the 0 power, and second to the third power. So the first term starts out with the highest exponent. It goes all the way down to 0 exponent, and the second term starts out at 0, and it goes all the way up to the third power. All right. So I'm going to delete this left-hand side here. Actually, I'm going to rewrite this. It's just going to go a lot faster. Okay, so 1. Okay, 2, that's 3 and 3, 4, 6, 4, 5, 10, 10, and 5. Okay. So again, this is our 0 exponent. 1, 2, 3, 4, 5. So if I wanted to do, let's just do a quick example here. Let's say I wanted to do 2x plus y to the 5th power. Okay, so what we're going to do is, here are your coefficients, guys. And notice how many terms there are. It's 1, 2, 3, 4, 5, 6. There are 6 terms when you have to the 5th power. And this is just kind of going back to what we just did a little while ago, right? If I have x plus y squared, wasn't that x squared plus 2xy plus y squared? So if there's 2 here, it's 3 terms. If there's 5, I have 6 terms. And that's why I have 6 coefficients. So this is how you expand it. It's coefficient of 1, so this is going to be a little bit of writing here. So it's 1 times 2x to the 5th. It's the first term to the biggest power, y to the 0. Plus coefficient of 5. 5 times 2x to the 4th, y to the 1st, plus next coefficient 10 times 2x to the 3rd, y to the 2nd, plus 10, next coefficient 10 times 2x squared times y to the 3rd, plus 5, 2x to the 1st, y to the 4th, and then plus 1 times 2x to the 0, y to the 5th. Okay, so that's completely expanded. And then if you just multiply it out, so 2 to the 5th is 32. So it's going to be 32x to the 5th and then y to the 0 is 1, so you don't write y to the 0. The next one, 2 to the 4th, is 16. 16 times 5 is 80, so plus 80 x to the 4th, y to the 1st, or y. 2 cubed is 8, times 10 is 80. 80x cubed, y squared. Okay, 2 squared is 4, plus 10 is 40. So plus 40. X squared, y to the 3rd. Next one, that's easy. It's 2 to the first 2 times 5 is 10, so it's plus 10 x y to the 4th. And then my last term, that's just a 2 to the x is 1, so it's plus y to the 5th. And that is 2x plus y to the 5th expanded. That's a lot easier than having to write out 2x plus y 5 times, foil, 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 and then start multiplying even bigger and bigger. I mean, it's actually kind of brutal. That's actually, it's very, very large. So it's much easier to use Pascal's triangle to figure this out. Okay, the thing I want to caution you guys about is when you're doing 2x to the 5th, make sure it's 2 to the 5th and x to the 5th, not just, sometimes people do this, is just 2x to the 5th. Okay, it's not that. It's 2 to the 5th, which is 32, x to the 5th. Okay, that's important. How's this going to help us? Well, it really is very helpful is when we have something like this. I'm going to write, actually it's going to be, if I wrote this triangle out, and I'm not going to, if I do this all the way down to the 11th line, so this is 0, and then I do this all the way, 1, keep doing all the ones all the way down to the 11th line. This is what the 11th line would look like. 1, 10, 45, 120, 210, 252, 210, 120, 45, 10, and 1. Okay, that is the 11th line. So actually, it's the 11th line, but it's the exponent is to the 10th. So let me write that down. This is really your exponent. Okay. So the deal is, what if I said, if I gave you a binomial and I said 3x minus 5 to the 10th power, and I said, what is the 6th term? That's a brutal problem. If I asked you the 6th term, you would have to multiply that whole thing out. It's just awful. You would cry. You would drop my class. It would be very, very sad. Okay, but if I said the 6th term, this is the deal. Look down here at the number. You got 1, 10, 45. So this is the 1st term, 2nd term, 3rd term, 4th term, 5th term, and 6th term. That's your 6th term. So what you're going to do is, that's your coefficient. It's 252, and we have 3x, that's your 1st term, and negative 5. So remember, the exponents, if it's to the 10th power here, this 1st term is to the 10th power, to the 9th power, 8th, 7th, 6th, 5th power. Okay, so let's see. They got right here 10, 9, 8, 7, 6, 5th power. Okay, and then of course, what's this one going to be? That's also going to be to the 5th power, because if you think about it, you can look at it a couple different ways. You can start it starts at 0, it goes to 1, 2, 3, 4, 5. Okay, and these numbers, those numbers, they have to add up to 10. They have to add up to that exponent. I mean, that's just a way to check it. All right. Then what you're going to do on your calculator is you're just going to do all the calculations. It's going to be kind of a big number, but you're going to do your calculations. So if I put on my calculator, okay, and the thing you got to be careful is make sure you put this in parentheses, guys. Because if you don't put in parentheses, here it doesn't matter so much, but if it was an even number, you'd make sure you want to get a positive value. All right. So anyway, you get for this problem negative 191,362,500. So it's negative 191,362,500 x to the fifth. Okay, let's check my calculation here. That's good. That is the sixth term. Okay? So, because remember, the first term is going to be x to the 10th. That's going to be x to the 10th, x to the 9th, x to the 8th, x to the 7th, x to the 6th, x to the 5th. All right? So, that's kind of the biggest use of Pascal's triangle, is finding some of these big binomials with a big exponent. And anyway, if you do that, you'll be good to go. That's it, math fans. That's Pascal's triangle. Again, it's only used for binomials. If you had like x plus y plus z to the 10th power, got to use something different. Okay? So Pascal's triangle is the way to go for binomials. All right, that's it, math fans. Have a good day. Goodbye.